I'm Michael Schofield from Dynon Avionics. We're here today to talk about our mission to bring more affordable and safety-enhancing avionics to type-certified aircraft. A bit about me. I'm our marketing director. I've been at Dynon for 15-plus years. I'm an old-timer, even though I'm still in my 40s at the company. And I fly a Glass Air Sportsman, which is actually an experimental, with 10 other people at my company, and so have good experience behind our product. A bit about our company. A lot of people that fly type-certificated aircraft are just starting to hear of Dynon. We're really well known in the experimental community, where we've equipped over 25,000 aircraft with avionics. If you just walk the flight line, especially the experimental areas, you'll find just a ton of Dynon-equipped aircraft. We started over 20 years ago. Last year was our 20th anniversary. Our founder is a serial entrepreneur that's had a lot of success in the semiconductor industry. He's also a pilot that has a Cessna 180 on floats in his backyard and a Beaver on the other side of the slip, and decided that he needed some better ways to monitor airspeed, to judge water, glassy landings, and he thought he could solve that with technology. Those experiments didn't pan out, but what he did do was hire a bunch of college interns and started a company that born really the most affordable avionics in 2003. Our company's grown since then. We acquired a competitor a few years back. These days, we're kind of three companies in one. The original Dynon is still predominantly experimental and light sport. Advanced Flight Systems is a sister company that is the competitor that we merged with a while back. And Dynon Certified is what we're talking about today. And what Dynon Certified is an outgrowth of the Skyview product line that we developed over a decade for the experimental market. So this is how it started. This was that first product that a handful of engineers developed in the early 2000s. We debuted this at what was an EAA air show at Arlington in 2003. And we actually still sell this same product today. It's been a super popular product for us. And what this was, if you're not familiar with it, this is the EFIS D10A. It was called the 10A because it had 10 instruments in one, including basically everything: airspeed, altitude, artificial horizon, turn rate, slip, skid ball. These days, all glass panels and all avionics do this and more, but in 2003, for $2,000, this was game-changing when everybody previously was installing a panel full of steam gauges. After we worked on flight instruments, we then moved into engine monitoring. Same product, just different features. We made them bigger because people like us with aging eyes don't like small screens. We combined them into combo units, and then we realized that the future of avionics was going to be not in these standalone instruments that do flight instruments or do engine monitoring, but integrated systems that can grow with our engineering capability and with your flying needs. And so forget the year, 5 years ago or so, actually here with EAA, we certified that very first experimental product. So for the first time, well, everybody had come up to our booth for years and said, hey, I love your stuff, the price is right, but I have a Cessna, I have a Piper, I have a Beechcraft. When are we going to get products that are thousands of dollars, not $100,000 that employ technology into our aircraft? So this is our first answer to that question, which was that original EFIS D10A, which was certified as a replacement for the attitude indicator. On the left there, that's the EAA's 172 that they did their test flying in. And then a few years later, we took our entire Skyview product line and certified that. And what Skyview is essentially everything in the aircraft minus a few small things. What it allows is the ability to take something like the inset picture, which is a beach, Bonanza, and turn it into what you see on the right, which is just a couple of screens that basically has all of the features that you might want in a modern aircraft. So what can Skyview do once you've upgraded a panel? So first is that same feature set that you saw in the original product, the primary flight display, except now it's more modern. It has synthetic vision. It has a full HSI. It has winds aloft and outside air temperature, ground speed, true airspeed, everything really. The engine monitoring is pretty compelling because not only does it give you gauges for everything, including all of your CHTs and EGTs, but because we know things about engine horsepower and fuel curves and things like that, we can tell you what % power you're making. We can tell you whether you're operating on the rich or the lean side of peak, even without having you, move the mixture to test it out. You just, in fact, the way I fly my airplane is I get to altitude, I do the big pull with the mixture, I look for the system to tell me that I'm lean of peak, and I'm looking for, in my airplane, about 8 gallons an hour, and I'm done. I don't have to worry about manifold pressure or throttle in a formulaic way like you would if you were just following the tables. So Skyview comes with a full moving map system and navigation system that has all of the capabilities that you'd find in a standalone unit or an app like FlyQ or ForeFlight, but it's in the system. And so if you're going out for, and this part of the system is for VFR use only. So if you're going out for a $100 hamburger, you're going to find our touchscreen interface the best way to dial in your direct to or your flight plan. If you're IFR, you're going to pair our products with an IFR navigator. We'll talk about that more in a little bit. This also has ADS-B in, traffic and weather, everything you'd expect from a moving map, airspace warnings, terrain alerting, the works really. This is just a shot of the flight planning engine. Nothing that you wouldn't expect, although what's really nice is that when you insert waypoints into your flight plan, it's never ambiguous where it's going. There's a nice little scrolling selector that makes it really clear how you're changing your flight plan, which isn't really clear if you look at some of our competitors. We can also echo flight plans, meaning display them on our screen from third-party IFR navigators. So if you're pairing our system with an Avidyne IFR navigator or a Garmin. Skyview is also home to a Modesh transponder that is also your 2020 compliant ADS-B outsource. What's really nice about this is because they're just modules that go into the system, they don't take up any real estate in the panel. So the transponder isn't a whole other thing in the radio stack. It's a thing on the screen that is touchscreen controlled, and most of the time, especially if you're flying VFR, you don't need to do anything with it because it has the ability to switch between air and ground modes automatically. So for me, I'm a VFR pilot, and if I'm not getting flight following, I don't even think about the transponder, and ATC never has anything to say, to me. We also have autopilot right now for a select few aircraft. We'll talk about that more in a minute, but the autopilot is super capable. It can fully couple to approaches when you're tied into an IFR navigator. It has heading mode, track mode, can climb and descend on vertical speed or airspeed, vertical nav, which can be sourced from our own flight plan or the IFR navigator if you're doing an ILS or an LPV approach. One neat thing, so if you look on kind of the left middle row, there's heading and track modes, and those are different and give you different results, but pilots often think they want heading, but they really want track. So if you're flying under ATC direction, they want you flying headings. They're doing the wind correction for everybody. But if I'm just flying, around the local area, and I know that I don't want to necessarily do a flight plan, but I know I want to overfly something. What you do is you put your autopilot in track mode, and track mode means a direction, kind of like heading, but but only what the GPS sees. In other words, what direction you're tracking over the ground. And so if I want to fly north, if I want to fly actually north, you put in track 360, and the airplane will track north. If there's wind, it's going to do the wind correction automatically. So if you have a Dynon autopilot, you can basically fly over the ground using autopilot without having to think about wind when you're using track mode. We also have an integrated comm radio, which has what I think is a revolutionary user interface. This is the control panel, and while with most radios, you have to either spin in frequencies or send frequencies from some database or call it up for some memory, with our comm radio, it's aware of the airport, and you can call up nearest airports. So if you come by our booth in Hangar D, we can demonstrate this a little easier than on a slide. But if I push that airport button to the left of the knob and then click in whatever the nearest airport is, here it's Salt Lake City, once the airport's loaded into the comm, then I have 4 buttons for the frequencies that are associated with it. So if I want to get the weather, I just smack the ATIS button, and now the weather frequency is all queued up. Then as we get closer, I'm going to go talk to tower, push that button, that frequency is all queued up. Same thing for ground, and ATC will pull up any departure or approach frequencies that are associated with that airport. So I can fly from Seattle, where I'm from, to Oshkosh, and basically just say airport nearest tower, and if there's not a tower, it'll bring up your CTAF frequency, and just do that over and over again every 10 or 15 minutes just to hear what's going on locally. Never spin in a frequency until I get to Ripon and have to get out the NOTAM to figure out what frequencies I need to be listening to. So that's a really neat feature that just changes the way your relationship with the comm radio. When I'm in other airplanes that aren't equipped with our products, I have to think, okay, where do I get the frequencies from a piece of paper or from an app, because I'm so not used to it anymore. But it's really workload reducing and lets you think about other things in the aircraft. So Skyview does basically everything in the airplane except for that IFR navigation piece. So let's say you're saying, oh, I'm interested. I want to upgrade my aircraft. What is it approved for? I don't know how, I can't really read this, but we are now approved in nearly 600 Piston single aircraft models. If it's under 6,000 pounds and has 7 or fewer seats, it's basically on this list. I think some of the composites aren't. So you can already install everything that we've already talked about in most Piston single aircraft. We're also approved in Piper Seneca, which was our first twin, with more to come in the future. Here are a couple of examples of Piston single aircraft, a Mooney M20 on the left, a Piper 32 on the right. And what's also neat about Skyview is you can do what our Mooney customer on the left did, and he basically just went with an entirely Dynon Skyview panel. But our customer on the right, I think that might be SoCal Flying Monkey if you know him on YouTube. I think that's his panel. So he already had done a bunch of upgrades, but really liked our products. I think he was a customer when we were, or admired us when we had our experimental product line, but didn't need an autopilot because we didn't have it available for his aircraft, and he had a different one, and didn't need some of the other subsystems. One of the nice things about Skyview is it's pretty configurable. You don't have to get everything. You can do just flight instruments or just flight instruments and engine instruments. It's pretty flexible that way. If you want to add the autopilot piece, because it involves mechanical changes to the airplane and brackets and engineering analysis, we actually have to do it model by model. So we actually have to get an example of the airplane, bring it in-house, do a bunch of engineering, documentation, analysis, and then do some rounds with the FAA to prove that we have an airworthy and compliant design. So we have that currently for 3 models: Cessna 172 Foxtrot through Sierra, Beechcraft Bonanza P35 through V35 Bravo, and then the Seneca 2, 3, and 4 models. 2, 3, 4, and 5. So if you have any of those airplanes, we can probably equip you with an autopilot. And then the question, because we know that most people, the autopilot, they might love Skyview and the flexibility and the capability and all of the workload reducing capability that it offers, but the autopilot really makes the sale. It's the thing that really makes it compelling, especially because the autopilot, because it's able to take advantage of all the computing and sensors that's built into Skyview, it's just not as expensive as a standalone autopilot, pretty universally. And so people ask, what's next? And the answer is, We have the airplanes on the screen, and I'll read them off, in-house. They're in progress with expected ship dates. And anything beyond that, we don't commit to. Some of these projects have slipped time-wise, a little bit because of COVID, a little bit because we're in Seattle, where the 737 MAX got a lot of attention with our regional FAA office. So we're not committing outside of this list, but these are the ones that we actually have in progress right now. So one is an expansion to the Bonanzas to include the 36s and A36s. That's due kind of now-ish. It was supposed to be done the first half of this year. It's going to end up being probably this quarter. The Cessna 182 will cover most likely the Echo and Onward models. We won't know for sure exactly which models for any of these until we actually have the approval in hand, because as we go through the later processes with the FAA, we end up sometimes not getting all of the models that we may have asked for. Another twin is the Beechcraft Baron 58 model. We'll include those, but not the pressurized ones. And then the airplane that's the furthest behind, probably in the schedule, and is probably into next year at this point, is the M20, the Mooney M20 series. And that's going, so our airplane is an example of what people consider the mid-length fuselage aircraft. So ours is a Juliet, M20 Juliet. So those aircraft around that model are the most likely to get approved. The very early ones, the short body models and the wood wing models, we're not likely to gain approval for with this effort. And then the very late models, the long body, will likely not be in this approval either. And so beyond that, beyond this list, there's infinity airplanes that we could go after. A lot of the popular ones that that we get requests for, things like the PA-28, where there are tens of thousands of you still out there registered. We hear you. We'd love to give a list of what's coming next, but we've changed our list even after we publish this. So now we just commit to what we have in progress, and beyond that is a little bit of a question mark. If you do end up choosing Dynon Skyview with or without the autopilot, there are two ways that you can buy, and this is kind of a unique thing that we do in the industry. One is that we do have now a pretty robust set of Dynon authorized installation centers, and that works how you'd expect. You go engage the installation center, they quote you up, with both the equipment and labor, and you give them the airplane, they deliver it back with an upgraded panel. Even if, and this is all on the website, of course, and even if there isn't somebody, let's say like in Nebraska and South Dakota, we also have a program for people that are becoming authorized installation centers that we can connect you to as well. So they're not technically centers, but they are game to install our products. The other way, and we did this because we came into certified, completely new. We were, pretty big in the experimental world, but didn't have a network of installation centers or shops. So as we're building that out, you can buy our products directly, even though you'll need to have it installed, professionally. And the way that works is we help you configure your system. You call our sales team; they're experts on our system. You put together the package that works for your aircraft. You then find an installer that you want to work with. For a lot of people, it might be, if you happen to be an IA that works on your own aircraft, you can buy directly. If your buddy's an AMP IA, and when I say IA, I mean you have to have at least an AMP with inspection authorization or be a shop to sign off on the STC as it goes into the aircraft. But a lot of people have, relationships with a local mechanic that has inspection approval. They might do the work themselves or with that person, get to know how the installation works a little bit better, and that works well for a lot of our customers as well. If you do the direct purchase route, you do have to, we won't sell it to you unless you actually have your installer lined up, so we will need the certificate number and everything. It doesn't affect the warranty, it doesn't affect the technical support you get, so whether you go with one of our installation centers or if you arrange your own installation, same deal. I'll go briefly through just what things cost. Everything we're talking about here is on our website. There's brochures at our booth that have real size cutouts if you want to sort of size up how things might fit in your panel. Price list, all of that stuff on the web. Here is the 10,000 foot overview. The floor of the pricing is about $10,000. That gets you a single Skyview screen with the primary flight instruments, the moving map, and then the backup instrument, which is the EFIS D10A. So you have dual redundant sets of flight instruments and the moving map, which is built in. And that's kind of the floor. Honestly, not many people buy that. Most people are going for either a well-equipped, where you've added in the transponder, the ADS-B in and out, comm radio, and whatnot. And when you're there, without autopilot, you're kind of between, call it $19,000 to $24,000 for a pretty well-equipped system. When you add autopilot, that adds for the Cessna another couple $1,000s. For the Beechcraft, it's under $5,000, and for the Seneca, it's under $10,000. So if you compare that with a standalone autopilot, you can't really find a twin. You can't really find an autopilot for a twin for under $20,000 these days. So here's the core system we talked about. So it's a single screen. It could be our 7 or our 10-inch display. It's backed up by that EFIS D10A, which is another full set of flight instruments. Along the bottom there, you'll see there's the ADAHRS, which is the small box that has all the sensors for your flight instruments and air data computer. The magnetometer for sensing magnetic heading, GPS for moving map and for other things that Skyview can do. Both Skyview and the EFIS D10A both have backup batteries. So that's really nice. A power issue in the aircraft, you'll lose nothing for an hour or more. It's time to land. You know, you've had a problem in the aircraft, but you're not going to be partial panel just because of a power failure. And there's no vacuum system, so you can forget about that. This is just a breakdown of how you get to all the bits and pieces that we talked about. If you want to add an additional display, it doesn't double the price of the system. You just add an additional display, and it gains all the capability of the whole system. So the smaller 7-inch display is $3,600, and the 10-inch screen is just under $5,000. This is the engine monitoring, which you can add or not add. We can do 4 6-cylinders. It monitors flaps and trim, all your CHTs and EGTs. And what that is comprised of is the module, which adds the capability to receive all of the sensors, and then all the sensors themselves. And for a typical 4-cylinder engine, you're going to be $1,700, $1,800. I think that includes fuel flow on that price, which enables the full fuel computer. And 6-cylinder is just under $2,000. Other options that many people consider, the things that are on the panel, one is the comm radio, which we already talked about. That's $2,200. Another is, if you're adding the autopilot system to the aircraft, you can control everything from the screen. I think I showed that in an earlier slide, the on-screen autopilot interface. There's also a dedicated control panel which you can install, which is essentially the autopilot control panel is essentially for workload reduction. So having dedicated buttons to engage and disengage all of your modes is super helpful. On the right, that is the knob control panel. So when you're flying around with autopilot and just flying in general, there are 3 things that you're going to adjust the most. Your altimeter setting is something you're always touching. And then if you're flying autopilot, adjusting altitude and heading or track, the knob control panel gives you dedicated knobs for each of those. If you opt for ADS-B traffic and weather, the system is aware of the METARs for the nearest airport. So you can spin the baro knob like we have there, but what you can also do if you have weather on board is just push it. And what it goes and does is it says, hey, what's the nearest airport? What's the weather there? What's the altimeter setting? Let's just set it to that. So again, you can fly across the country, similar to with the comm radio, where you're just going airport to airport. You just push the barrow button every 10 minutes, and you just get the updated altimeter setting. Other behind-the-scenes things that aren't in the panel but are options are the ADS-B in and out, so the mode S transponder that automatically switches from air to ground, and then the receiver to get traffic and weather in the cockpit. That's $3,200 for both of those. If you're going with an IFR navigator, which most people do, there's a box that connects to that. It has what's called the AirInc 429 signaling. The autopilot involves servos, of course, and bracketing in the structure of the aircraft that move the control surfaces. And then one neat thing that, especially if you're helping your installer, or if you are an installer and want to really get the volume of installs you can do up, is that we have, and this kind of comes from our experimental roots, where not everybody's an electrical engineer. There are lots of folks that love building airplanes but aren't really excited about the wiring. So over the years, we've developed a pretty robust set of harnesses and connectors for almost all of our displays and modules. And one nice thing about Skyview is everything, and if you just have If you just have a, say a Cessna that you bring to a shop, you'll never actually see this until you take a peek behind your panel. If you have a certified aircraft and you haven't done work in a long time, or you've done work piecemeal, you might have a kind of a rat's nest of wire behind the panel. But what Skyview has is most things connected with what we call Skyview Network, which is a 9-pin connector. It looks like an RS-232 serial connector that connects all the modules together. So if you come to our booth at Hangar D and peek behind, that's basically what a panel looks like. There's not much there. This is just the pricing on what we just talked about. ADS-B in traffic and weather is $900. The Mode S transponder is $2,300. Comm radio is $2,200. The knob panel is $250, and the IFR connectivity kit is $500. For a typical aircraft, this is kind of a stack up of those harnesses that you would use. Be a few $100s worth of harnesses. And we've talked. I guess I've mentioned this in bits and pieces. If you are going to be flying IFR, Skyview can do everything you need. You've got two complete sets of flight instruments, engine instrumentation, alerting, all of that. The one thing that we don't have ourselves is an IFR approved navigator. So most people are going to take Skyview and pair it to either an Avidyne. This is an IFD 440. If you have something that's already in the aircraft, maybe it's a 430 or 530 or a GTN, those work great too. And then the other piece we don't make ourselves is an audio panel. We love the audio panels from PS Engineering. If you have something in the aircraft, it may work. One reason that people do choose to upgrade their audio panel with their Skyview upgrade is that the electronic elements, like Skyview, can alert, and some audio panels don't have a ton of auxiliary inputs that you can that you can put things in terms of the older audio panels. So PS Engineering, there are quite a few companies that make audio panels, but PS makes the ones that we like. Once you're flying, you're going to wonder where you get data from for the databases. So for the IFR navigator, you go get their certified data for the approaches. But as I mentioned, we have a full built-in flight planner, moving map, and the data for that's free. It's on our website every 28 days. All the airports, airspaces, fixes, and all of that are just on our website. You download it to a USB stick, you bring it to the airplane, you update the aircraft. If you want the digital versions of the paper, so your VFR sectionals, your IFR low and high charts, plates, airport diagrams, all geo-referenced so that you can see the airplane flying over them, you can get that from a partner of ours, Seattle Avionics. Sells a year subscription to all of that for $99. Folks are also curious how much it weighs, and of course it varies by which options you go with, but in all of our test airplanes, we've removed between, I think, 30 and 80 pounds of stuff, so you actually will almost always recover useful load when you install Skyview. And part of that is hoses, vacuum pumps, old instruments, steam gauges are all like a few pounds a piece, where in contrast, our screen is a few pounds, and then there are modules which are, not much bigger than what I have in my hand here. And then if, you may be out there and you don't have one of the aircraft that we yet have approval for autopilot in particular, and you might say, hey, can I give you my airplane? And, you'll give it back to me in 6 weeks. And we can't take you up on that offer because it often takes quite a bit longer. But what we are interested in getting are pictures of aircraft structure. So when you're down for annual and if your aircraft is apart, and if you can just get in there, even with just like an iPhone, and areas where autopilot servos may have already been installed, if you have a legacy autopilot that just doesn't work anymore, we're interested to see for essentially any aircraft that we don't have approval for, what those aircraft look like on the inside. Because what we end up having to do through our analysis and engineering is go find data for the Mooney, for example. So we have an M20J, and that should be the same as a whole bunch of future and past Moonies, but we've learned from previous projects that sometimes there are changes that aren't well articulated in the engineering information we can find. So real world data, we're super interested in. If you go to our website, there's a link to submit that. And then another question we get is, what's the deal internationally? So we have an FAA approval for our instruments, and there are some countries where they just accept our STC. That's often smaller countries that don't have their own real robust FAA equivalent. And then there are other countries where there are reciprocal agreements. Canada's one of them, except for the fact that our STC was based on a more modern version of the rules than they had decided to agree on what is transportable. That changed this week, where the FAA in Canada updated the agreement. So as of Monday, yesterday, you can now put our stuff into Canadian registered aircraft. We don't have Europe yet, although it's something that'll be coming at some time in the future. So that's probably the one we get asked about the most.